Hello and welcome to today's problem, 1-for-1 linked list cycle. So given the head of a linked list, you want to determine if the linked list has a cycle in it. And it's a cycle if there is a node in the list that can be reached out again by continuously following the next pointer. Okay, so we're given this example over here. You're given basically the head of the linked list, and you want to return true because there is a cycle, and for this one, you also want to return true because there's a cycle here. This one return false if there's not. Okay, so a way of solving this would be using something called Floyd's algorithm. So Floyd's algorithm, pretty much what it is a way of detecting cycles within a linked list. So to best explain it, you can have a slow pointer and a fast pointer. And you can have the fast pointer move twice as fast as the slow one. Eventually, once you cycle through, if there's a cycle, for example 1, we have a pointer at 3, the slow one, and the fast pointer also at 3. Once we move forward one step, the slow one goes to 2, the fast one goes to 0. Move it again. The fast one goes to 2 and the slow one goes to 0. And you move it again, the fast one goes to -4 and the slow one goes to -4. Notice that when they're both equal to each other, that's when you're able to tell that it's a cycle. Because if there isn't a cycle, then the farthest the slow one will reach is half of the linked list's length, and for the fast one, it'll reach the ends by the time the slow one gets to the halfway point. So you can kind of tell that there's going to be a cycle by checking to see whether or not the slow one and the fast one are going to be equal, and that's how you're going to be able to tell whether or not there's a cycle. So I can go ahead and begin implementing this now. What we can have is slow and fast, and we'll have that to equal both the head. So while slow and fast dot next. Actually, we don't even need to check whether or not the slow one exists. While fast and fast dot next, we can check to see. First we have to move slow and make that equal to slow dot next, and then we do fast equals fast dot next to move forward twice. If at any point if slow equals fast, then you know that you would have reached the same, you know that you have reached a cycle because of what we mentioned earlier. So at that point, we want to return true, and if you get through the whole thing without having reached that true statement, then we'll assume there's no cycle, so we'll return false. So let's walk through this example again with like 1 and 2, for example. So with 1, it's slow, it moves over here. The fast one goes to 1 again, it shoots like that, and the slow one goes from 2 to 1. And then from there, it also jumps again, it hits 1 again, that's when it hits the cycle again. And for this one, it'll be false because by the time the fast one reaches the end, the slow one will have already reached the halfway point. So it'll never be equal to each other. So we'll go ahead and run this example. Yep, accepted. If you go ahead and do a quick submission, that's good. So the time complexity of this is O of n, and the space complexity is O of 1 because you're not storing anything in the memory. Okay, well, thank you for watching.